take a look at solving some quadratics with square roots. Now there's lots of different ways to solve quadratics, so we want to work on identifying when to use which method. So folks, as we take a look at this one, we know it's a quadratic because the highest degree of any term is 2. And if you notice, there's no degree of a term with 1. So since there's no just x value, that tells us that we can easily solve this using radicals. Now if we do have an x squared and an x, that's when we want to then take a look at possibly factoring, completing the square, or using the quadratic formula. So just know when to kind of use each method. So as we take a look at this, since there is no b term, let's start by getting our x squareds to one side, and let's use a radical equation. So my first thing I'm going to do is I'm going to isolate my x squareds to the right side. So I'm going to subtract 3x using my subtraction property of equality from both sides, leaving me with 18 equals 2x squared. My goal is to get the squared by itself, so I can use a radical as an inverse operation. So my next step is to do the inverse of multiplying by 2, which would be to divide both sides by 2. That will cancel. 18 divided by 2 is 9, and 2 divided by 2 is 1, leaving me with x squared. Now I'll use the radical, taking the square root of both sides. A square and a square root will cancel one another out, leaving me with x equals. Now remember, radical equation, whenever you take the square root of something, you end up with two results. So we get the positive and the negative square root of 9, which in this case it is a rational value, so it's positive and negative 3. Now once we do that, we do need to go back and check our work to make sure that it's not an extraneous answer, and if so, we need to mark it as so. So as we take a look, we have 3, and let's try the positive value first. So 3 squared plus 18 should equal 5 times 3 squared. So as we check this first one, 3 squared is 9 times 3 is 27 plus 18 equals 3 squared is 9. 9 times 5 is 45. Now let's take 27 plus 18 and we get 45. So our positive 3 does in fact work. It is not an extraneous solution. Let's try our second one. So 3, and then we have negative 3 squared plus 18 equals 5 times negative 3 squared. So as we take a look at this self-check, the quantity of negative 3 squared is 9. 9 times 3 is 27, plus our 18. Negative 3 squared is 9, times 5 is 45. And we end up with 45 equals 45 again, so therefore both are good solutions. Let's take a look at another example. So here again, we have a quadratic. We know that because it has the highest degree of 2. And we can see that there's no b value, even though it's not written in standard form, again, because there's no just x to the power of 1. So therefore that indicates that we can use a radical to isolate for the x value. So let's start by using our inverse operations again. And let's start by the inverse of dividing by 2 is going to be to multiply both sides by 2. Using our multiplication property of equality, which will result in 4x squared plus 10 equals 10. Undo our addition with subtracting 10 from both sides and our subtraction property of equality, resulting in 4x squared equals 0. The inverse of multiplying is to divide by 4 using our division property of equality, resulting in x squared equals 0. Our last step is to take the radical so the square root of both sides. Square root of x squared is just x, and we get a positive and a negative anytime we take the radical, 0. But folks, in this case, 0 is not neither, it can't be both positive and negative, it's just x equals 0. There's our solution. Good luck on your trial problems.